Does anyone remember what an oscillation is? Or a vibration? Either way you want to call it. Yeah, so one full motion, it's not so much a lap, it's like back and forth. But yes, it's one full motion of what you're doing. So I'm going to say one full back and forth motion. Now, you can say a bunch of things. You could say to and fro. You can say forwards and backwards. You can say up and down. You could say there and back. Those are all fun. Anything that shows I go from A to B, wherever that is, and back to A. It can be like a curved loop. It can be up and down. But it can't be like a circle because that gets complicated. Okay? But a forward and a backwards thing. Okay, good. Look at that. We got one. All right, I like this. All right, amplitude. Who's got amplitude? We got this. I know. You guys have it. I feel it. Feel it. Not feel it. Yeah, Tyler.
The distance the oscillation travels from the center.
Yes. It's the largest distance from equilibrium. So amplitude is the largest distance. So largest distance of the oscillator. So whatever's vibrating, whatever's oscillating. So the largest distance from equilibrium. Okay, so the furthest you can get from equilibrium, that's what your amplitude is. Okay, whatever you pull it back, the furthest you pull it back, the furthest it goes, that's what amplitude is. Okay. Period. One more. We're almost there. I'm hoping this is the easiest one because we talked about it a lot. Jalen? 2. Yep. It's the time for one oscillation. Excellent. Time for one oscillation. Man, Jalen carried the team over here. And you're even gone more days. I love it. Absolutely love it. Okay? All right. So we've got the first 3 done. These are ones we talked about before break. Again, chances are you might have forgotten them, and that's okay, but I wanted to talk about them again because you're going to see them in this next section on waves. So what I want you guys to do is I want you to go ahead and do the rest of them here up through, it does go on to the second page, up through K. So I want you to go all the way up through K. All of these, with one exception, are in the glossary. They're also on these pages, 358 to 359 and 361 to 362. You can find them in the book in those pages. So if you're a person who likes context, this is where you want to find it. If you're a person who's like, nah, give me the answer, then the glossary is what you want. There is one I want you to circle that is medium. We are going to do it together. We're going to do medium together. Your book gives you context clues as to what medium is, but it's not particularly clear as to what a medium is. And I want to be specific on what a medium is. So go ahead and work on the rest of number 1. Again, it's D, F, G, and then H through K. H through K. So basically go until you get to number 2, but skip E. Okay, I'm going to give you some time to do that. I'll bring around books if you don't have books at your table or if you don't have enough or something like that. But we've got the first 3. Do the rest of them there. See what you're able to come up with. And then we will go over them, and then we'll see what we can do with the rest of them. All right, let's start with a wave. Okay? Your book gives a couple of different definitions, one of which I'm not wild about, and one that's a little bit better. See, Gabe, I think you had the one I wasn't wild about. What did you say for a wave?
Oh, wiggle in space.
Yeah, so your book says a wiggle in space and time. I don't like that definition very much because I think it's a little on the silly side. Like, wiggle. I don't know. Like, it's not my favorite. So what's a different definition for what a wave might be? What's a different idea for what it might be? You're describing a wave to me. How would you think about it, David?
Regularly repeating a different that transports energy from one place to another.
Yeah, so that's the better definition that I like. So here's what it is, and I'll try to break it down to make it kind of simple because there is a lot of words going on there. I think of it this way. So it's the oscillation, because remember we talked about what oscillation was. We said it's a full back and forth motion. And really, I should probably add this, it's repeatable. So what that means for a wave, it's an oscillation, okay? So it's repeatable, it's back and forth, okay? Oscillation of a medium, we're going to talk about a medium in a second, that transports energy. This is the big part. That transports energy is important. You need that in your definition somewhere. Okay? The transports energy, it needs to be in your definition. And the reason why is that is literally the point of waves. The point of waves is to transport energy. When I talk, it transports my sound energy to you. When wind blows on the water and it creates waves, it transports the wind energy. Okay? When this heat from the sun hits the ground and heats up that air, and you see like this shimmering air because of how hot the surface is, that's waves. That waves are transporting the energy it gets from the sun. So waves transport energy. That's literally their purpose. That's what they do. Any definition you give me needs to have that in it. Needs to have transporting energy. Okay, so what is a medium? So a medium is the material a wave travels through. Now, it's worth mentioning there are waves that can travel without a medium. Okay? There are waves that you can travel without a medium. They're called electromagnetic waves. We will talk about them. We're not going to do them right now. We're not going to do them this unit. This unit is only mechanical waves. This unit is waves that physically go through stuff. Okay? So examples of things, waves that physically go through stuff, water waves. Okay? Water travels physically through, or the energy travels physically through the water. Okay? So that's one example. Another example of a physical wave would be, we're going to play with slinkies. We have a lab that will do with slinkies. I got 50-foot-long slinkies. You're going to make waves go through the slinkies. Okay? Yeah. Here's another one. This is probably one that you wouldn't think of, but is a good example of this. If you've ever been to a football or a baseball or a basketball stadium and they do the wave, that is a wave, right? Because it's a repeatable back and forth motion. People go up, people go down, and it transports energy, the energy of the people standing and sitting, and it transports that energy around. It is literally an example of a wave. So if I ask for an example wave and you describe the wave to me at sporting events, that is right.
Wait, I have a question.
Yeah.
So say they do like a wave at like a football game.
Yeah.
Where's that energy going and does it affect the game?
Well, of course it affects the game. You're a player, you know, you feel the energy of the crowd.
A little bit of energy. On the side.
Where does that energy go? It's a great question. That part of the wave is a little hard to translate into the wave like at a game. That's easier to see in like water waves, right? Because when the wind blows on the wave and when it hits the beach, you can see the energy is transported on the beach. But when you're talking about going around a stadium, that's a little harder to describe.
So like,
The way I would describe it is it's like the energy. It's the energy that the person has when they're standing and sitting.
oh,
Right?
okay.
So like that energy technically doesn't oscillate around the stadium, but the energy still exists in what the motion is, the up and down motion.
That makes sense.
Okay? Alright, good. So that's what a wave is. Alright, let's see up here. Dylan, what you got for crests? Perfect. Yeah. So a crest is the highest point of a wave. Now, high is subjective, has to do with what your orientation is. But we think of it as like looking forward at a thing. Is it, how high up is it? Okay. Let's see. Tapua, what you got for G? What's a trough?
Like the lowest point of the wave.
Yeah. So this one's the opposite, lowest point of the wave. Perfect. All right, on to the back. Jamal, what you got for, I don't know which of them it is. What you got for wavelength?
The distance between reflected trough or identical parts of the wave.
Perfect. I'm going to simplify it down, but that's exactly right. So it's the distance between, I'm going to just use the last part you said, between two identical points on a wave. Now, here's why I say that as opposed to crest. Like, so a lot of you had, it's the distance between two crests on a wave. That's fine. The reason why I say this is because you're not always going to have two crests in a wave if it's a small wave. Like, if the wave is down, up, down, back to the middle, like, that's not two, you can't do two crests on that one. So you would have to do two other identical points, like the two troughs. You could do trough to trough. Or you could do midpoint to the next time it hits the midpoint. Like, it's going down at the mid, next time it's going down at the mid. That would also work. Okay? So you're just looking at the different points there. All right. Frequency. Christian, what you got for frequency? Yeah. So I'm going to add to it just slightly, but I like it. So the number of oscillations. So you said back and forth. That's what an oscillation is. Number of oscillations in an amount of time. I'm just going to add that. So number of oscillations in an amount of time. Okay. Oscillations in an amount of time. The unit. So if it's oscillations per second, oscillations is a counting number, so it doesn't have a unit. Time is measured in seconds, so the unit is 1 over seconds. But there's a name we use for that. Okay? And that is hertz. Just think it's going to hurt so bad if you forget what the unit is. It's a good one. Thought you liked it. Yeah.
That was funny.
Yeah. Thought you liked it. Yeah. I spent all day working on that one. All right. So we got oscillations in amount of time. We got the unit. The unit is 1 over seconds or hertz. Hertz is what it is. We're going to come back and talk more about frequency. You've actually done frequency already. You just didn't know you did it already. But we'll talk about frequency. Okay. And Tristan, what you got for transverse? Okay. So transverse wave is a wave where the particles in the medium travel perpendicular. So you said right angle is the same thing. To the wave. All right, so the particles go up and down and the wave goes forward. Someone give me an example. What would be a wave where the particles go up and down but the wave goes forward? Water is a great example. Water wave. Water goes up, it goes down, it goes up, it goes down, but the wave goes forward to the beach. So the actual particles, if you're in the water, you go up and down, you go up and down, you go up and down. That's all you do, whereas the wave goes forward. Okay? So that's an excellent example of a transverse wave. All right, and a longitudinal one. Longitudinal one.
Longitudinal is such a good word.
You like that one?
Yeah, it's actually a nice word.
Zach, what you got for longitudinal? Okay, so a wave where the particles in the medium, and we want to be a little more specific about them. Wave where the particles in the medium travel parallel to the wave. So they travel in the same direction that the wave does. Same direction that the wave does. This one is a little harder. This one's a little bit harder to find an example for. And that's because you're not used to seeing as much. Yeah, go ahead. What do you think, Elise?
Sound.
Sound is a great one. That's the one I use. Now, the only downside of sound is you can't see it. But if you think about this, your vocal cords vibrate forward and backwards like this. What direction does the wave go? That way. So they're vibrating this way. The sound wave is going that way. And that's what it's doing. It's not like your vocal cords are going up and down like this and the air is coming out that way. It's they go back and forth. The sound goes back and forth, goes that way. Okay, so sound is your best example of this one. There's lots of examples, but they're harder to see when you're looking at them. So the example I like is sound. Sound is a longitudinal wave. We'll do some other examples. What we're going to talk about for the next class is we're going to look at how do these things relate to each other. What are the different, how do we relate wavelength and crests and troughs and amplitude, how we put all those things together. So we'll work on those next time. Any questions for me?